Scientists didn't just listen to whales anymore. For the first time in history, they spoke to them, and the whales answered back. Not with random splashes or meaningless noise, but with structured responses that followed rules, rhythms, and patterns scientists had never fully understood before. Hidden beneath the ocean for millions of years, a complex language was always there. We just didn't know how to hear it. What changed everything wasn't a new submarine or a better microphone. It was artificial intelligence. By feeding decades of whale recordings into advanced AI models, researchers uncovered something unsettling. Whales weren't just communicating emotions or instincts, they were sharing information, social bonds, identity, and possibly even warnings. Messages passed between families, across regions, and maybe across entire oceans. And once scientists realized they could understand this language, they tried something no one had ever done before. They spoke back. What followed forced researchers to rethink intelligence, communication, and humanity's place in the natural world. Because now that we can hear what whales are saying, the real question becomes far more uncomfortable. Were they ever talking to each other, or were they talking to us? It began with a single sound, a deep, hollow click that rolled through the water like a pulse. To humans, it was just another noise in the vast chaos of the ocean, but to sperm whales, that click carried meaning. For decades, scientists recorded these sounds, stacking up hours of audio that all seemed frustratingly similar at first. Pops, knocks, rhythms with no obvious translation. Yet patterns kept surfacing. Certain sequences repeated with uncanny precision. Some clicks appeared only when pods reunited. Others surfaced during deep dives or when calves stayed close to their mothers. These weren't accidents. The timing was too exact, the structure too consistent. Whatever these whales were doing, it wasn't random. Researchers began calling these patterns codas, short bursts of clicks arranged in specific rhythms. Over time, it became clear that whales weren't just producing sounds, they were following rules. A pause placed just slightly too early or too late could change the entire sequence. Some codas even seemed tied to specific individuals, almost like a vocal signature passed through sound alone. The problem wasn't a lack of curiosity, it was a lack of tools. Decoding these patterns by hand meant staring at spectrograms for hours, comparing waveforms and guessing at meaning. It was like trying to translate a language you couldn't see, written by a species that never stopped moving. Scientists could hear the structure, but they couldn't prove it. For years, whale communication sat in scientific limbo. Clearly complex, clearly intentional, but still out of reach. And until someone found a way to see the hidden order inside those clicks, the ocean kept its secrets. And that's when a new listener entered the water, one that didn't just hear sound, but searched for rules. That new listener wasn't human. It was artificial intelligence. The moment marine biologists paired whale recordings with advanced machine learning models, everything changed. Instead of manually scanning audio for familiar patterns, researchers could feed massive amounts of sound into systems designed to recognize structure, the same kind of AI used to understand human language. The ocean, for the first time, became readable. This effort became known as the Cetacean Translation Initiative, or Project CETI. Its goal was ambitious and unsettling in equal measure: to decode sperm whale communication and uncover whether their clicks followed something closer to grammar than instinct. If successful, it wouldn't just rewrite marine biology, it would challenge what we believe about intelligence itself. The ideal testing ground was found near Dominica, where sperm whales live in stable, multi-generation family units. These whales don't just pass through, they stay, socialize, and raise their young together for decades. That stability gave scientists something they'd never had before: long-term social context. Hydrophones were placed deep underwater, and non-invasive tags were attached to whales, recording not just sound, but movement, orientation, and interaction. Within a few years, Project CETI collected over 50,000 hours of whale audio, the largest dataset of its kind ever assembled. But the breakthrough didn't come from size alone. It came from how the data was used. Transformer-based AI models began analyzing the recordings, not for volume or pitch, but for relationships, timing, rhythm, repetition. What the models uncovered was stunning. Codas weren't just repeated clicks, they followed rules of tempo and spacing. Some clicks were elongated, others compressed. Certain embellishments appeared only in specific social moments. When mapped over time, these patterns behaved less like noise and more like language, flexible, rule-based, and shared. Even more striking, these structures weren't universal. Different pods followed different rules. Certain sequences were learned, refined, and passed down, generation after generation. The implication was impossible to ignore. Long before humans built cities or wrote symbols, whales had already developed a communication system rich with structure and meaning. And once that realization set in, one unsettling thought followed close behind. If this was truly a language, then structure alone wasn't the most important part. Meaning was. As the AI peeled back the structure of whale codas, something even more revealing emerged. Variation. Not just between individual whales, but between entire families, regions, and oceans. To human ears, these differences were almost invisible. To the AI, they were unmistakable. Each sperm whale unit had its own way of speaking, the rhythm of clicks, the spacing between them, the subtle flourishes added at the end of a sequence. These weren't random quirks, they were dialects, shared vocal traditions that marked belonging. A calf born into one unit doesn't simply start clicking, it spends years listening, mimicking, and slowly refining the exact patterns used by its family. This learning process takes time. Young whales can spend more than a decade mastering their unit's dialect, copying elders with near-perfect accuracy. And once learned, these dialects remain remarkably stable. Some core codas have stayed consistent for generations, allowing researchers to identify family lineages just by listening. A single sequence can reveal who's speaking and who they're speaking to. But whale dialects aren't frozen in place. When adult males leave their birth units and join new social groups, their vocal patterns begin to shift. Over time, their clicks adapt to match the dialect of the pod they associate with. It's the acoustic equivalent of picking up a new accent, not by accident, but through social awareness. This kind of flexibility changed everything. Dialects aren't just sounds, they reflect relationships, alliances, and identity. Some scientists suspect these differences influence cooperation, conflict avoidance, and even mate selection. In other words, language isn't just how whales communicate, it's how they organize their society. Before AI, spotting these changes took months of human analysis. Now, machine learning models track dialect evolution in real time, detecting subtle shifts in rhythm and ornamentation as they happen. In some regions, those shifts are accelerating, suggesting that whale language is still evolving, right now, beneath the waves. Which raises a question that's hard to ignore. If whales have dialects, culture, and the ability to change how they speak depending on who's listening, then these aren't simple calls. They're conversations. And once scientists realized that, listening no longer felt enough. For decades, humans listened to whales like outsiders, recording conversations we weren't meant to join. Project CETI set out to change that. Once AI revealed the rules behind whale codas, the rhythms, spacing, and social context, the next step became unavoidable. If the structure was understood, could it be used to speak back? This wasn't about replaying recordings. Mimicry wouldn't prove understanding. The challenge was far more delicate, generating entirely new codas that followed the whale's grammatical rules, matched the dialect of a specific pod, and carried the right social tone, without copying any real whale's voice. In human terms, it was like forming an original sentence in a foreign language and hoping native speakers wouldn't immediately spot the mistake. The first tests took place off the coast of Dominica, near a pod that researchers had studied for years. Submerged speakers were lowered into the water. One by one, the AI-generated codas were played: greeting patterns, reunion-style sequences, social engagement calls. Then, the team waited. The response was immediate. A mother and calf changed direction and swam toward the source of the sound. In another test, an entire pod paused its movement, returning clicks timed precisely with the artificial codas. Some whales lingered longer than they typically would, repeating variations of the same patterns, as if paying unusually close attention. Across multiple sessions, nearly 70% of the AI-generated codas triggered a response. In several cases, the whales didn't just reply, they modified the sounds, adding extra clicks or adjusting the rhythm in ways scientists had previously observed only during high-engagement social exchanges. That detail mattered. It suggested recognition, not confusion. For the first time on record, humans hadn't just heard another species speak. They had constructed original sentences in a non-human language and received answers. The line between observer and participant had blurred. And after the experiments ended, something even stranger began to appear in the data. Patterns that hinted the conversation might not have stopped when the speakers were turned off. As Project CETI's database expanded, the AI began flagging patterns that didn't fit the warmth of greetings or social play. These codas appeared sharper, more urgent, and they showed up in very specific places. When researchers compared recordings from remote, quiet waters to those captured near shipping lanes, fishing zones, and industrial sites, the contrast was impossible to miss. Certain click sequences spiked almost exclusively in areas dominated by human activity. In the open ocean, far from noise and traffic, those same patterns were rare or absent altogether. One sequence drew particular attention: a rapid burst of tightly spaced clicks repeated in sets, followed by an unusually long pause. It wasn't used during feeding or bonding. Instead, it surfaced when large vessels passed nearby. The timing was too consistent to ignore. Whatever this coda represented, it wasn't casual. AI cross-analysis revealed something even more unsettling. Variations of the same sequence appeared in recordings from pods thousands of miles apart, groups that had never interacted directly. That suggested the pattern wasn't a local habit, it was spreading, passed from pod to pod, region to region, like shared knowledge. Some researchers began to speculate that whales were exchanging environmental intelligence, warnings about danger, noise, or intrusion. If true, their communication system wasn't just social. It functioned like a distributed network, broadcasting information about changes in the ocean itself. In areas with intense human activity, these codas appeared more frequently and with greater complexity, as if the message needed emphasis. Subtle changes in rhythm and ornamentation suggested refinement, the acoustic equivalent of underlining a sentence. The possibility was uncomfortable. If these were warning signals, whales might have been sending them for decades. Which raises a troubling thought. Mass strandings, sudden migrations, abandoned feeding grounds. What if these weren't mysteries at all? What if they were responses to signals we simply never understood? For the first time, the ocean didn't feel silent. It felt ignored. And while sperm whales may be issuing quiet warnings, another species has chosen a very different way to be heard. While sperm whales seem to communicate in warnings and boundaries, orcas have taken a far more direct approach. Off the coasts of Spain and Portugal, something unprecedented began unfolding. Orcas started targeting boats. At first, the encounters seemed harmless. Young whales circling sailboats, nudging rudders, lingering in the water longer than expected. Then, the behavior escalated. By 2024, more than 600 incidents had been recorded, including several vessels that were left disabled and at least a few that sank. What shocked researchers most wasn't the damage, it was the pattern. Nearly all encounters involved just two closely related pods, and many of the whales participating were juveniles. This wasn't chaos, it was learned behavior spreading through a social group. Scientists believe the behavior may have started with a single female orca, often referred to as White Gladys, possibly after a traumatic encounter with a vessel. Others appeared to copy her actions, but imitation alone didn't explain what came next. Before converging on boats, orcas were recorded using long-range whistles that could travel for miles. During the encounters, those whistles shifted into synchronized high-frequency buzzing. After the rudder was disabled, the whales emitted coordinated calls unlike anything documented before. These weren't hunting signals, they weren't play calls. They were consistent across encounters, suggesting a shared communication strategy. Researchers describe this as a real-time cultural cascade, behavior and the sounds that guide it spreading rapidly through a population. What makes this even more unsettling is the speed. Sperm whale language evolves slowly, shaped over generations. Orcas, under pressure, seem capable of reshaping behavior and possibly communication in just a few years. It's adaptation at breakneck speed. That raises an uncomfortable question. Are these attacks accidental play that spiraled out of control, or are they something more deliberate, an expressive response to intrusion? The sounds used during these encounters don't match any known vocalizations tied to feeding or social bonding. They appear to be new. If so, orcas may be doing something unprecedented, developing a form of communication born specifically out of conflict with humans. Unlike subtle whale warnings, this message is impossible to ignore. And if two intelligent marine species are responding to human presence in such different ways, what does that say about what the ocean is trying to tell us? Taken together, these discoveries point to something far bigger than isolated experiments or unusual behavior. Two highly intelligent species are responding to the same pressure, us, in radically different ways. One through structured warnings woven into an ancient language, the other through rapid cultural shifts paired with unmistakable action. Throughout human history, sudden changes in communication have marked moments of upheaval. New languages emerge during revolutions. Coded speech appears under oppression. Information spreads fastest when survival is at stake. Now, similar patterns seem to be unfolding beneath the surface of the ocean. Sperm whales appear to be adapting their language gradually, embedding information about human activity into codas shared across vast distances. Orcas, by contrast, are compressing that process into years, not generations, developing new behaviors and vocal cues almost in real time. Both point to the same conclusion. These animals aren't just reacting, they're responding intentionally. What makes this moment so unsettling is timing. For millions of years, whale communication evolved beyond our awareness. Now, just as we've learned how to listen, their messages are changing. That suggests something new has entered their world, something disruptive enough to reshape how they speak. If language reflects perception, then these shifts may reveal how whales and orcas see us, not as background noise, not as passing observers, but as active forces in their environment, ones they must communicate about, adapt to, and possibly resist. Which leaves us with an uncomfortable realization. We've crossed a threshold. For the first time, we're not just studying non-human intelligence, we're being acknowledged by it. And once a conversation begins, silence is no longer an option. For millions of years, whales spoke beneath the waves, their complex rhythms and patterns invisible to human ears. Sperm whales passed down generations of knowledge, their codas carrying identity, culture, and perhaps even warnings. Orcas, on the other hand, adapted rapidly, using sound to coordinate action and assert control over their environment. Both species are communicating in ways we are only beginning to understand, and the common thread is clear. We are part of the story now. AI didn't create their language, it simply gave us the key to hear it. And once we could listen, we realized something profound. The ocean has always been full of messages, but we've only just learned to receive them. What we do with that knowledge matters. Will we continue to ignore the warnings hidden in codes, or will we start paying attention to the intelligence that surrounds us? For the first time, humans are no longer eavesdroppers. We've entered a dialogue, one that could reshape how we understand intelligence, communication, and our place in the natural world. The whales have been talking all along. Now, the question is simple, yet urgent. Will we listen?